All right, guys, here are your notes on the properties of water. So our central question we're going to be using today is, how do the properties of water allow it to be an essential molecule for life? Sorry, there's your central question. All right, so water is a molecule. It's the most needed molecule, both organic or inorganic. It's something that all living things require. So one of the things we want to talk about is that water is a polar molecule, which, if you remember from chemistry, means that it is a slightly charged molecule and can form hydrogen bonds easily with other water molecules. In addition, the water, or the oxygen in water, is slightly negative. So you see here that slightly negative charge, and it allows it to easily bond with other molecules that are slightly positive, such as another water molecule. There are four main properties of water that we'll talk about. That's cohesive behavior, which also includes adhesion. It can moderate temperatures. It expands upon freezing and is a great solvent. So let's talk about cohesive behavior. So cohesion is when water molecules bond to each other. So like in the first example about water being polar, I can have two water molecules and they will easily bond with each other. Adhesion is with water and other non-water molecules bond with each other. So, I could have some other molecule here, and that's going to bind with water very easily. So an example in this is in plant behavior, plant stems, where cohesion helps the transport of water against the gravity in plants. So water has to move up a plant, so it's moving against the gravity, and it's doing that because of cohesion. For adhesion, the water will stick to the plant cell walls. So you've got your cell wall here, okay, which makes up the stem, and then water can not crawl, but it can stick to that and again move up that stem. Okay. Here's just an example. So these sieves are going to be where water can move up through using cohesion and adhesion. Surface tension is a measure of how hard it is to break the surface of a liquid. So one thing to remember is that cohesion is related to surface tension. So it's something that we see with an example here, bugs that can walk on the surface of the water. It gives, the surface tension allows bugs to walk on water, which allows them to obviously not have to swim, and they can get from one place to another, and it opens up how much their food source. High heat capacity, so it takes a lot of energy to heat 1 gram of water, and because of this, water is able to absorb or release large amounts of energy without necessarily changing its own temperature. This is important because we don't want our bodies, which is mostly made up of water, to be able to change temperatures so easily. Or in bodies of water like lakes and oceans, we don't want extreme temperatures to be able to change the temperature so easily as well. Usually bodies of water like the ocean and lakes will only fluctuate in temperature 2 to 3 degrees depending on where it is and how big it is. But that's, it's a pretty small temperature change considering some places that are in where it's really cold, really hot. Okay. So the moderation of temperature, we mentioned about temperature not being able to change so easily in water. So we call that specific heat. So it has a high specific heat. So specific heat just means, the amount of heat that can be absorbed or released for 1 gram of substance. It could be water, it could be any other substance. For water, when you break hydrogen bonds, you absorb that heat, and when the hydrogen bonds form, you release it. Vaporization is just when you have liquid going to gas. Evaporative cooling, for example, when we sweat, that is an example of evaporative cooling happening on our bodies. Okay, so that evaporation actually helps to cool us off, so the evaporation of the sweat. Okay, upon freezing, water is actually more stable. It expands, so it's a better insulator when it's in ice form rather than liquid form. So what happens is, a pond freezes over, so here's our pond. Okay, it freezes over, but it's only gonna freeze the top layer. Sorry, that's a terrible straight line. And then the fish down here are going to still be alive because now, even though it's really cold out here, the temperature is manageable down here, which allows them to survive even when it is freezing outside. Otherwise, if the whole thing froze, then all those fish would die. So this is a great property of water to help support life. So water as a solvent means that other molecules and substances can easily dissolve in water. Why is that important? Well, it makes it easier to transport nutrients to various areas of a cell or the body. Okay, a lot of times you'll hear me talk about solvent and solute. Solvent is the thing that you're dissolving something in, so water would be a solvent. A solute would be the thing that water is dissolving, so sugar or salt would be an example here. An aqueous solution is going to be a solution that includes water. Okay, so when you're talking about, excuse me, solvents, we look at two terms: hydrophobic, which is water-hating, and hydrophilic, which is water-loving. A hydrophobic molecule won't have an affinity for water, thus it can't dissolve in water. But a hydrophilic molecule does have an affinity to water and thus will dissolve in water. Okay, so when we talk about disassociation of water, we have to understand pH and understand where that comes into play. So in order to understand pH and why we have varying pHs, we have to understand that water will dissociate or shift its atoms from one water molecule to another. So this creates two ions called hydronium and hydroxide. So the hydronium ion has extra protons. The hydroxide has lost a proton, so it's less. So you'll see here those charges tell you what's going on with the charge. More protons because it's positive, less protons because it's negative. Okay, when we transfer a hydrogen atom, we're calling it a proton because it actually has one less proton than it does electrons. Okay, obviously we know with a pH scale, we have 7 as being neutral, 1, 13, and in pure water, the hydrogen ions and hydroxide ions are going to be equal to each other. When you add acids or bases, you're modifying the hydroxide and hydrogen ion concentration. Okay, so what does that mean? Well, if you're going to increase hydrogen ions, so increase, that means you're adding acids, and then decreasing hydrogen ions means you're adding bases. So bases are over here, acids over here, okay? The other thing to remember is when it comes to pH, we want to maintain a pretty consistent pH. How do we do that? Well, the way we do that is with pH buffers. Okay, living cells need a pH of about 7, and if they change any higher or lower, it could have some pretty damaging effects. So buffers actually exist to minimize effects of an acid or base. Acid or base, okay? So the buffers will keep, depending on the buffer it is, will keep that pH as close to 7 as it can get, even with the addition of something that is acidic or something that is basic, okay? So that's the end of that. If you have any questions, please again, make sure you let me know in class. And